The San Jose Municipal Code, specifically Chapter 15.4, Section 15.4, 270 regarding service and feeders, addresses the capacity requirements for electrical services. Section 15.4, 271 specifically deals with increases in service capacity. According to subsection B, increase, if calculating the new electrical load after a modification results in an increase of more than 10% in the ampere rating of the feeder or service, then the feeder or service must be increased to at least 100% of the new load. Therefore, if a renovation increases the total electrical load by more than 10%, an upgrade to a 100 amp or higher main electrical panel may be necessary. This determination depends on several factors, including firstly, the existing total load in the home, secondly, the estimated load increase due to the renovation, and thirdly, the capacity of the existing main panel. To determine if an upgrade is required, you need to follow these steps. 1. Calculate the existing total electrical load. This is achieved by adding up the wattage of all appliances, lighting, and other electrical devices in the home. 2. Estimate the load increase due to the renovation. Determine the wattage of all new electrical devices, lighting, and other components that will be installed as part of the renovation. 3. Compare the total load. Add the estimated load increase to the existing total load. If the sum is more than 10% higher than the capacity of the existing main panel, an upgrade may be required. Due to the complexities of electrical load calculations and code compliance, consulting with a licensed electrician is strongly recommended. A qualified electrician can perform the necessary load calculations accurately and ensure that the electrical system meets all applicable codes and standards. They can also assess the existing electrical system for any potential issues and recommend appropriate solutions. The electrician can also help with understanding the specific requirements of the San Jose Municipal Code and any other relevant regulations. They can also ensure that all work is performed safely and up to code. Load calculations involve several factors, including the square footage of the home, the number of small appliance circuits, the number and size of any large appliances such as air conditioners or electric ranges, and any other electrical loads. The National Electrical Code, or NEC, provides guidelines for calculating these loads. Article 220 covers branch circuit, feeder, and service calculations. Understanding the NEC requirements is crucial for accurately determining the necessary capacity of the electrical service. For general lighting loads, the NEC specifies a minimum load of 3 volt amps per square foot for dwelling units, as per NEC Table 220.12. Small appliance branch circuits, which serve kitchen and dining areas, must be calculated at 1500 volt amps each, according to NEC 220.14H. Laundry circuits are also calculated at 1500 volt amps each. For appliances like electric ranges, ovens, and dryers, specific demand factors are allowed, as outlined in NEC Table 220.55 for ranges and ovens, and NEC 220.54 for dryers. These demand factors recognize that not all appliances will operate at their maximum power consumption simultaneously. Heating and air conditioning loads are calculated based on the nameplate rating of the equipment. The largest of these loads is then used for the overall service calculation. Motors are another significant load, and their calculations are covered in NEC Article 430. The full load current of the motor is used for the calculation, and for multiple motors, demand factors may apply. After calculating all the individual loads, they are summed to determine the total connected load. This total connected load is then adjusted by any applicable demand factors to arrive at the total calculated load. This calculated load is the basis for determining the required size of the service and feeder conductors. Conductors must be sized according to their ampacity, which is the maximum current they can carry continuously without exceeding their temperature rating. NEC Table 310.16 provides ampacity ratings for various conductor types and sizes, based on their insulation type and installation conditions. Overcurrent protection devices, such as circuit breakers or fuses, must be sized to protect the conductors from overload. The overcurrent protection device should not exceed the ampacity of the conductor it is protecting, as per NEC 240.4. Voltage drop is also a consideration when sizing conductors. Excessive voltage drop can cause appliances to operate inefficiently or not at all. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. To minimize voltage drop, larger conductors may be required. Grounding is a critical aspect of electrical safety. The grounding system provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and energizing the circuit. NEC Article 250 covers grounding and bonding requirements. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The equipment grounding conductor connects the non-current carrying metal parts of electrical equipment to the grounding system. Bonding is the process of connecting all metal parts together to create a continuous electrical path. This helps to minimize voltage differences and reduce the risk of electric shock. When upgrading an electrical panel, it is important to ensure that the new panel is properly grounded and bonded. The size of the grounding electrode conductor must be based on the size of the service entrance conductors, as per NEC Table 250.66. Arc fault circuit interrupters, or size, are required in many areas of the home, including bedrooms, living rooms, and dining rooms. A size detects arc faults, which are dangerous electrical conditions that can cause fires. Ground fault circuit interrupters, or GFCIs, are required in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs detect ground faults, which occur when current leaks from a circuit to ground. They quickly interrupt the circuit to prevent electric shock. Surge protection is also recommended to protect sensitive electronic equipment from voltage surges. Surge protective devices, or SPDs, can be installed at the service entrance or at individual branch circuits. They divert surge current to ground, preventing it from damaging equipment. The NEC provides guidelines for selecting and installing SPD in Article 285. When performing electrical work, it is essential to follow all applicable codes and standards. The NEC is the primary electrical code in the United States, and it is updated every 3 years. State and local jurisdictions may also have their own electrical codes, which may be based on the NEC or may have additional requirements. It is important to be familiar with the specific electrical codes that apply in the area where the work is being performed. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Working with electricity can be dangerous, and it is important to take all necessary safety precautions. Always de-energize circuits before working on them and use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable performing electrical work yourself, it is best to hire a licensed electrician. Licensed electricians have the training and experience to perform electrical work safely and up to code. They can also provide valuable advice and guidance on electrical projects. The specific requirements for electrical work can vary depending on the location and the type of work being performed. It is always best to consult with a qualified electrician or local building official to ensure that all work is performed in compliance with applicable codes and standards. The calculations for determining the load are essential. Firstly, for lighting, calculate the square footage of each room and multiply it by 3 volt-amps per square foot according to NEC Table 220.12. Secondly, for small appliance circuits, include 220-amp circuits for the kitchen and dining area, each calculated at 1500 volt-amps per NEC 220.14H. Thirdly, for laundry circuits, include 120-amp circuit calculated at 1500 volt-amps. Fourthly, for large appliances like ranges, ovens, dryers, water heaters, and air conditioners, use the nameplate ratings of these appliances. Demand factors from NEC Table 220.55 can be applied to ranges and ovens, and NEC 220.54 for dryers. Fifthly, for heating and air conditioning, use the larger of the heating or cooling load. Sixthly, for motors, use the full load current from NEC tables 430.247, 430.248, 430.249, and 430.250, and apply any applicable demand factors. After calculating all individual loads, sum them up to find the total connected load. Apply demand factors where applicable to reduce the total calculated load. This calculated load is then used to determine the required service size. The service entrance conductors must be sized to carry the calculated load continuously without exceeding their ampacity. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductors from overload. The grounding system must be properly installed and connected to provide a low impedance path for fault current. All metal parts of the electrical system must be bonded together to minimize voltage differences. Arc fault circuit interrupters, or of size, must be installed in bedrooms, living rooms, and dining rooms to protect against arc faults. Ground fault circuit interrupters, or GFCIs, must be installed in bathrooms, kitchens, and outdoor locations to protect against ground faults. Surge protection is recommended to protect sensitive electronic equipment from voltage surges. The electrical panel must be properly labeled with circuit directories to identify each circuit. All electrical work must be performed in accordance with the NEC and any applicable local codes. It is important to use qualified electricians for all electrical work to ensure safety and compliance with codes. The total load calculation involves assessing every electrical device and outlet within the home. The process includes, firstly, lighting circuits, where the general lighting load is determined by multiplying the square footage of the house by 3 volt amps per square foot as specified in NEC Table 220.12. Secondly, small appliance circuits, which are calculated at 1500 volt amps each, and typically 2 are required for kitchen and dining areas per NEC 220.14H. Thirdly, individual appliance loads for larger appliances like refrigerators, dishwashers, washing machines, and dryers. The nameplate rating in volt amps or watts is used for each, noting that 1 volt amp is approximately equal to 1 watt for resistive loads. Fourthly, cooking appliances like electric ranges and ovens are calculated based on NEC Table 220.55, which allows for demand factors since these appliances don't continuously draw their maximum power. Fifthly, heating and cooling systems, with the nameplate ratings for air conditioning, heat pumps, and electric heaters are used. It's important to consider the largest of these loads. Sixthly, water heaters are calculated using the nameplate rating, typically 4,500 to 5,500 watts for a standard residential water heater. Seventhly, motors and other equipment with motors are calculated based on their horsepower and voltage, using NEC tables 430.248, 430.249, and 430.250 to determine the full load current. After listing all loads, apply appropriate demand factors as permitted by the NEC to account for non-simultaneous use. The total calculated load determines the required service capacity. It is critical that this calculation be accurate and that all applicable codes and standards are followed to ensure the safety and reliability of the electrical system. When considering an upgrade, firstly, examine the existing panel to determine its amperage rating. This is usually printed on the panel's main breaker. Secondly, calculate the existing load as described previously. Thirdly, estimate the additional load due to the renovation, including new lighting, appliances, and outlets. Fourthly, add the existing load and the additional load to determine the total anticipated load. Fifthly, compare the total anticipated load to the existing panel's rating. If the total load exceeds 80% of the panel's rating, an upgrade is recommended. This is to prevent overloading the panel and to provide capacity for future expansion. The upgrade process may involve replacing the main breaker, the meter base, and the service entrance conductors. The new panel should be sized to accommodate the total anticipated load and any future load growth. All work must be performed by a licensed electrician and must comply with all applicable codes and standards. Upgrading a service involves several steps, including firstly, planning and permits, where you consult with a licensed electrician to assess the existing electrical system, calculate the new load requirements, and determine the appropriate size for the new service. Permits are typically required for electrical work, so the electrician will handle the permit application process. Secondly, disconnecting the old service, which requires the utility company to disconnect power to the home. The electrician will coordinate this with the utility company. Thirdly, removing the old equipment, which involves removing the old meter, service panel, and service entrance conductors. Fourthly, installing the new service, which includes installing the new meter base, service panel, and service entrance conductors. The new service entrance conductors must be sized according to the calculated load requirements and the NEC. Fifthly, grounding the new service, which is essential for safety. The grounding system must comply with NEC requirements and typically includes a grounding electrode, such as a ground rod or a connection to the metal water pipe. Sixthly, connecting the new service, which involves connecting the new service entrance conductors to the utility company's power lines. The electrician will coordinate this with the utility company. Seventhly, inspecting the new service, which is required by the local building department. The inspector will verify that the work was performed in accordance with the NEC and local codes. Eighthly, energizing the new service, which requires the utility company to reconnect power to the home after the inspection is approved. It's crucial to consult a licensed electrician.